Hello, this is Mr. Huber. In this lesson, we're going to learn about simplifying radical expressions, specifically square roots. Okay, a radical doesn't have to be a square root. It might be the more common one, the one we've seen the most, but it could be a third root, fourth root, any root. We're going to work on square roots and how to simplify those. If you recall, a square root means we want a factor that's multiplied by itself to get that number. So for instance, we'd have the square root of 25. Okay, the square root of 25 is the square root of 5 times 5, or the square root of 5 squared. You have a number times itself. That's what the square root of 25 is. What number times itself would give us 25. Okay? The square root of 81. That would be 9 times 9, which would give us 81. All right, so when we want to simplify radical expressions, we want to find perfect square factors. Okay? Not every number is going to be an exact square root, like 81 would give us 9. We might have something like 32. There's no integer, no number times itself to give us 32. So we want to break down 32 into factors where one of them is something we know the square root of. So for instance, 32 can be written as 16 times 2. So the square root of 16 times 2, and we know the square root of 16. So the square root of 16 would give us this 4 that's out in front of the radical. And then 2 stays inside the radical. We can't simplify the square root of 2 any further, so 4 square root of 2 would be our simplified form for the square root of 32. Let's look at the square root of 72. Okay? You want to find a factor that you actually know the square root of. Right? 72, we could turn that into some different things like 3 times 24. Okay? But if I make this 3 times 24, let's write it on the side here, because that's not what I want to do to help me simplify it. I don't know the square root of 3 or 24. Like here, we know the square root of 16. That helps us because we can square root the 16 to get the 4 simplified outside the radical. Here, I can't square root either of those, so that's not particularly useful. So the square root of 72, I might want to figure out what perfect square factor does it have, such as 36 times 2. And 36, I know the square root of is 6, and then square root of 2 would just remain the square root of 2. I can't simplify that any further. Now if you did over here the 3 times 24, we can talk about how you could further break that down. Okay? You could further break down 24 to even, let's say, 2 times 12. And then we'd have 3 times 2 times 12. And then you could break down the 12 to, let's say, 2 times 6. And now I'm looking, oh, hey, I've got, a factor there of 2 times 2. And the 6 could be 3 times 2. And now, oh, hey, I've got a factor of 3 and 3. And you could find pairs of factors. So that's another way you can break this down. You can make factor trees and find pairs of factors as well. So you could do it that way. We can work on both methods, but particularly I like to find perfect squares that are factors, and then I can take the square root of, like 36. I know the square root of that, which is 6. Okay, the square root of 50, for instance, right? I don't necessarily want to break that down into 5 times 10 because I don't know the square root of 5, I don't know the square root of 10. So that's not going to be particularly useful. Okay, but what I could do is make this the 3 outside there still. We'll talk about what to do with that 3 that's outside there, and then 25 times 2. Okay? Now the square root of 25 is 5. So when I take this 25, this is multiplying what's out in front of the radical. Because when I have a 3 root 50 here, that's 3 times the square root of 50. So when I take the square root of 25 as 5, it's 3 times that 5. So this is going to give me 15 square root of 2. So that number we simplify out multiplies what would already be out in front of the radical. In these ones, there's a 1 here. So when I take the square root of 36, which is 6, and multiply it by, there's a 1 there, I just get a 6. All right, so keep that in mind. This number is multiplying the radical. This is 15 times the square root of 2. Just like if it was 15x, it'd be 15 times x. All right, now let's have you practice some. Try to simplify these radicals, and then let's see how you do on them. All right, so number 1, we have the square root of 108. Okay, again, it's an even number, so you could make it 2 times 54. But you don't necessarily know the square root of 2, you don't know the square root of 54, so that might not be the most useful way to go. So what else can we do? Well, you want to try perfect square factors. You can just get your calculator and say, okay, can I divide 108 by 4, 9, 16, numbers that you are familiar with the square root of. Okay, so you want to be able to divide it by one of those numbers to be able to use that as a perfect square factor. So yeah, you might say, okay, 4. So I'm going to make this the square root of 4 times 27. Okay? And if you do that, that's fine. That's 2 square root of 27. Well, now the square root of 27 can still be simplified. So we wouldn't want to stop there. It's like simplifying a fraction. We want to simplify it all the way at first. That's okay. So I'd want to make this 2 times the square root of 9 times 3, because I know 27 is 9 times 3. Okay, well that's great because I know the square root of 9. That's 3. That's going to come out here and multiply the 2. I'm going to get 6 root 3 for my final answer. So I could have known 108, if I divide it by 36, I get 36 times 3. So I could have gone right to 36 times 3, and the square root of 36 would be the 6. But you don't have to do it in one step. Okay, just like simplifying a fraction. You don't have to do it in one step if you're not familiar with the greatest perfect square factor. That's fine. All right, the square root of 96. So let's look at that. The square root of 96, this would be 2, and then the square root of 16 times 6. The square root of 16 is 4, so that'd be 8 root 6. And that'd be my answer. Square root of 6 can't be simplified anymore. We have negative 7 times the square root of 300. So when you see numbers that are hundreds, 100 is something you know the square root of, so I would make this 3 times 100. Maybe because I know the square root of 100, which is 10. I have a negative 7 still in front of there, so it's going to be negative 70 times the square root of 3. Okay? The 10 that comes out multiplies the negative 7 to give me negative 70 root 3. And then here I have 10 square root of 150. So that's going to be 10 times 25 times 6. Square root of 25 times 6. I know the square root of 25. So again, that's going to come out and multiply here and give me 50 root 6. Can't simplify that any further, so that'd be my final answer. Always look at the end and make sure, is it simplified all the way? Look, okay, the square root of 3, can that be simplified anymore? Do any of these numbers in here have perfect square factors that I'd be able to simplify, like here when I had the 27, and I could continue to simplify that a little further. All right, before we do some more simplifying radicals, Google, the company Google, the name they came from a mathematical term. It's a large number with how many zeros? Like a million is 1 followed by 6 zeros. A billion, 1 followed by 9 zeros. Do you know how many zeros there are in one Google? And it's spelled a little differently mathematically. It's Googol. So Google is there, 1 followed by 100 zeros. That is a Google. 1 followed by 100 zeros. All right, let's simplify more radicals. This time we're going to see where there's variables involved. So when we simplify radicals with variables, we want to find how many pairs of factors there are inside the radical. Just like when we simplified the square root of 25, it's because 5 times 5, we get a 5 out in front of the radical. So now I want to find out how many pairs of x's instead of pairs of 5s, or whatever the variable might be. In this first case, it's an x. So I want to find how many pairs of x's there are. So one thing you could do is you could look at this and say, okay, this is the square root of x squared times x. So the square root of that x squared is going to get 1x out in front of the radical. So it's going to be x root x. Right? And this next one, how many pairs of x's are there? So this would be 4 pairs of x squareds. Really what you can do is say, okay, I'm going to take 8, my exponent, divide it by 2. That gives me 4. There's going to be 4 pairs of x's. It would be x to the 4th. In this next one, I simplify the number 20 and the square root of x to the 5th separately. So let's just talk about the 20. Okay, the square root of 20, right? I could turn that into 4 times 5, right? So that's going to be 2 root 5. And if I take x to the 5th, I'd have 5 over 2. 2 is going to 5 twice, with 1 left over, right? With a remainder of 1. So when I have that now, I'm going to have 2 x's come outside the radical, so this is going to be the 2 that we had, x squared, and then inside the radical, 5x. That would be my final answer for that problem there. Right? I have the 2, which I got from the square root of 4. This 5 stays inside the radical. And then x to the 5th. There's 2 pairs of x's, right? X squared, with 1 left over inside the radical. All right, this next example, 8, we can make 4 times 2. So this 8, this could be the square root of 4 times 2. That would give me a 2 out in front of the radical. So times the negative 3 is going to be negative 6. Now I'd have m to the 7th. That's m to the 3rd out front of the radical. And inside it, we're going to have an m left over. I should write the 2 as well. So I'm going to have 2 and then m. And then my x, there's just x to the first. So this x is x to the first, right? If they don't write an exponent, x to the first. So I can't simplify that at all. That's just going to stay an x inside the radical. And then y squared, that's going to give me one single y out in front of the radical. So I have negative 6 m to the third y, square root of 2 mx. All right, let's have you try a few now. So you work through these and let's see how you do. So in number 5 here, we have the square root of m to the fifth. So keep in mind, that's like the square root of m squared times m squared times m, right? That's 5 m's. Here we'd have 2, 4, 5 m's. Really we're looking at how many pairs of m's. So we take 5 divided by 2, there would be 2 pairs of m's with 1 left over. So the 2 pairs of m's means that's what will come outside the radical, the 1 left over, and we'd have m squared times square root of m. Now the next one we have a number to work on, 40. So 40 can be 4 times 10, so that could be 4 times 10, the square root of 4 times 10, so I get a 2 out in front of the radical. The end of the fourth, so this end of the fourth, there's 2 pairs of n's there, so n squared. And there's not going to be any left over inside the radical, so we're going to have square root of 10. So 2n squared, square root of 10. All right, square root of 98 in this next one. Square root of 98, that's 49 times 2. The square root of 49 times 2. So that's going to be a 7 out in front of the radical times the negative 5. It's going to be negative 35. Okay, inside the radical, we're still going to have the 2. Right, this 2 stays inside the radical. Now we look at x to the sixth. So x to the sixth, there's 3 pairs of x's. 6 divided by 2 is 3 exactly, so there's exactly 3 with none left over. X to the third. And then y to the third, 3. The exponent 3 divided by 2, how many pairs of 2's are there? There's 1 pair of y's with 1 left over inside the radical. So negative 35, x to the third y, square root of 2y. All right, let's look at number 8. In number 8 here, we have the square root of 162. So this might take a while. These are ones where maybe you're going to have to divide by, can I divide it by 4? Can I divide it by 9, 16, 30, 60? You can divide it by 81. This is 81 divided by 2. 81 is a number we would know the square root of. The square root of 81 is 9. So we'd have 9 times a 3 that's there is 27. Inside the radical, we're still going to have a 2. Then I have m to the fifth. So that's 2 m's that are out in front of the radical with 1 left inside. X to the fourth. So that's x squared. There's 2 pairs of x's there. So x squared. And then I'd have y. That just stays inside the radical. There's nothing to simplify that. So I have 27 m squared x squared in radical 2my. So when you're simplifying radicals, you're looking for pairs of factors that are the same to be able to square root and simplify out in front of the radical. When it's a number, look for those perfect square factors. And it might not be the ones you come to right away, but find factors, divide by 4s, 9s, 16, 25 numbers you would know the square root of to see if you can get those as factors to then simplify. When you're dealing with the variables, and you have a radical there, square root, dealing with the variables, see how many pairs there are. So if there's 5 m's, that means there's 2 pairs with 1 left over. That's what stays inside the radical. All right, always look at the end and say, is there any way I can simplify this any further? If there is, then maybe you have to go that next step. Right? So simplifying radicals with square roots, you can continue to work on those so we can build that knowledge base of working with radicals that we're going to need when we go through and add and multiply them and do other work as well.